So what does it mean for a machine to be athletic? We will demonstrate the concept of machine athleticism and our research to achieve it with the help of these flying machines called quadricopters, or quads for short. Quads have been around for a long time. The reason that they're so popular these days is because they're mechanically simple. By controlling the speeds of these four propellers, these machines can roll, pitch, yaw, and accelerate along their common orientation. On board are also a battery, a computer, various sensors, and wireless radios. Quads are extremely agile, but this agility comes at a cost. They are inherently unstable, and they need some form of automatic feedback control in order to be able to fly. So, how did it just do that? Cameras on the ceiling and a laptop serve as an indoor global positioning system. It's used to locate objects in the space that have these reflective markers on them. This data is then sent to another laptop that is running estimation and control algorithms, which in turn sends commands to the quad, which is also running estimation and control algorithms. Suppose that we want this quad to not only hover, but to also balance this pole. With a little bit of practice, it's pretty straightforward for a human being to do this, although we do have the advantage of having 2 feet on the ground and the use of our very versatile hands. You can notice that this quad is making fine adjustments to keep the pole balanced. How do we design the algorithms to do this? We added the mathematical model of the pole to that of the quad. Once we have a model of the combined quad-pole system, we can use control theory to create algorithms for controlling it. Here you see that it's stable, and even if I give it little nudges, it goes back to the nice balanced position. We can also augment the model to include where we want the quad to be in space. Using this pointer, made out of reflective markers, I can point to where I want the quad to be in space, a fixed distance away from me. Striking a moving ball is a necessary skill in many sports. How do we make a machine do what an athlete does seemingly without effort? Machines can not only perform dynamic maneuvers on their own, they can do it collectively. These 3 quads are cooperatively carrying a Skynet. They perform an extremely dynamic and collective maneuver to launch the ball back to me. Notice that at full extension, these quads are vertical. In fact, when fully extended, this is roughly 5 times greater than what a bungee jumper feels at the end of their launch. The algorithms to do this are very similar to what the single quad used to hit the ball back to me. Mathematical models are used to continuously replan a cooperative strategy 50 times per second. Everything we have seen so far has been about the machines and their capabilities. What happens when we couple this machine athleticism with that of a human being? What I have in front of me is a commercial gesture sensor, mainly used in gaming. It can recognize what my various body parts are doing in real time. Similar to the pointer that I used earlier, we can use this as inputs to the system. We now have a natural way of interacting with the raw athleticism of these quads with my gestures. Some conjecture that the role of play in the animal kingdom is to hone skills and develop capabilities. Others think that it has more of a social role, that it's used to bind the group. Similarly, we use the analogy of sports and athleticism to create new algorithms for machines, to push them to their limits. What impact will this breed of machine have on our way of life? Like all our past creations and innovations, they may be used to improve the human condition, or they may be misused and abused. This is not a technical choice we are faced with, it's a social one. Let's make the right choice, the choice that brings out the best in the future of machines, just like athleticism and sports can bring out the best in us.